Happy Solar Pro Saturday, everyone. Mike Patterson here with KLN Solar, back with a long delayed resumption to our training videos. Today, we are going to be going over what to look for in plan review and reviewing the engineering plans on your projects. So what we're going to look at today is basically a 1,000-foot view of what to look for. When you see your designs, you see your engineering plan sets come back. What do you want to look for in a SolarEdge system? What do you want to look for in an in-phase system? And especially when these systems have batteries. We're going to start with SolarEdge plan sets. As a review, SolarEdge are optimized inverter systems. Every panel should be tied to an optimizer. This optimizer adjusts the voltage, but does not change the energy from DC to AC. And there's going to be one or more inverters for the entire system. With a SolarEdge battery, it is DC coupled, which means the battery is connected directly to the inverter. And there should also be a backup interface, which you can think of like the brains of the system and also the transfer switch. So first, you want to review what's in your proposal. This is a project that we're working on right now. And you can see in Solo, it comes back very sloppy because of all of the different obstacles that we have to work around on the roof, and also this customer having a very large electrical consumption where we needed the maximum amount of panels that we could fit. So this system had 72 Qcell 400 panels. They are the G10A Plus series. We had two SolarEdge SC11 400 inverters. We used a line side tap, concrete tile mount, and an attic run. There are no batteries on this system. So then when we get our plans, the first thing we want to look at is, did they basically follow our design? For a lot of customers, that might be very important. You can see here they closed up some of these gaps, like I would expect them to, getting tighter around some of the obstacles. But more or less where we put panels is where they have panels, and there would be no expected change in production here. Then we want to look at the equipment list that's on the engineering plans. So you can see they listed 72 Qcell 400s, two SolarEdge SC11 400s, 72 of the S440 optimizer. That's what I like to see for a 400-watt panel. There are still some people using the older P401s. For a 400-watt panel, I definitely want to see the S440s now. You see there's a junction box, and then the connection equipment that is required, and then CT meter, because this customer asked for consumption monitoring. And finally, the junction boxes, those are code essentially for an attic run. That's where all of the wiring from panels comes together, gets combined, and goes into the attic. Now you want to check the mounting hardware. With this, you are looking at what type of roof it is. In this case, it is a concrete tile roof. And this is a piece of mounting hardware that is used specifically for concrete tile, especially for this barrel tile. You can see it attaches to the roof, comes out from under the tile, goes up and holds the rails. Ironically, for this project, this particular mount ended up being rejected by coding. So we ended up having to go back to the tile replacement. But that's unique to Florida with our wind codes here. So other areas you may well see this mount. The biggest thing you want to look for is just make sure if you have a tile roof, for example, that you don't see a shingle mount or vice versa. Now for the complicated one. This is what gets everybody. We want to look at the line drawing. And we're going to go into some detail here. So on this particular system, I mentioned it's a very large system. We have a total of 6 strings. And they're called strings because the panels are all connected in a row. I don't want to confuse you. A SolarEdge inverter is 100% not a string inverter. But we're using common terminology. You'll also see that with Enphase. They refer to grouped panels as strings. And you can see with each one of these, we have 12 panels, 12 panels, 12 panels, and so on in each of our strings. And they're divided up going into the junction boxes for the attic run and going into each specific inverter here. So we have a total of 3 strings going into each inverter, fairly well separated, so we're not overloading one inverter or the other. You can see that they have an optimizer listed for each panel. That is very good. It's required for the system to work, but you'd be surprised what is sometimes missing. And then also on here, this is for coding. They list that the optimizers have integrated rapid shutdown. Again, very important for certain areas with fire codes. Now, coming out of the inverter, in this case, you can see that we have our monitoring, our consumption CT, around the meter. But the inverters themselves are feeding into their own dedicated load center. Again, it's fairly specific here just because of how large this system is. Going through 120 amp fuse and coming into a load side tap. So that is one thing that is actually different on this project than what we had spec'd out. We listed a line side tap. The engineers determined that they were going to use a load side tap. Functionally, they're equal in my opinion, so I have no problem with that. And that, as a review, is just basically a way that we are connecting the system without having to worry about doing a D-rate on, in this case, it's a twin 200 amp panel system. So remember, you want to make sure all the equipment matches the original equipment. And like I said, they went for the load side tap rather than the line side tap. And that's just specific to what type of meter and what that utility requires. We expected that with Seco, the particular utility for this one. But when you're speccing out your adders, there's not a difference between line side and load side tap. Now, what about if we had batteries in this system? So everything that I mentioned before still applies. You still want to look at all of the solar portion of the system, but then in addition to that, you need to look and make sure that they use the correct battery. Do they have the correct number of batteries? Do they have an Energy Hub inverter spec'd out, and is it the correct size? Do they have a backup interface? And if it's a partial home backup, do we have either a sub panel or a smart panel going in? Just today, for example, I got a plan set to review that should have had 2 batteries on it, and they only had 1. So it was something we had to flag and get corrected. Again, we're looking at the line diagram. These wires here are all coming down from the panels on this system, and we're coming into the 11400 Energy Hub in this case. A reminder, with SolarEdge DC coupled batteries, you have to use the Energy Hub inverter. Now from here, we also have 2 of the SolarEdge batteries connected directly into the inverter. As a reminder, they are DC coupled. And then this is all feeding into the backup interface. And the backup interface is what is essentially determining if the system is functioning on grid or off grid. It's acting as the transfer switch and the disconnect from the utility in the case of an outage. From here, they're going into a junction box, 60 amp fuse, feeding into a line side tap in this case on a 200 amp panel. And once again, we have consumption CTs on the system. Everything with an Energy Hub has integrated consumption CTs. So it is by default, as long as your installer bothers to connect. Now, what about Enphase? It'll be very similar, but some differences here. So as a reminder, Enphase is a microinverter system. Every panel gets an inverter, and the energy is converted to DC from DC to AC at that panel level. Their battery is AC coupled, which means it has a separate attachment to the home. The battery has its own inverters, so it does not connect in with the panel inverters. Here's a system that we did, a large Enphase system with some batteries. We had 78 of the Canadian Solar 395 panels, 78 IQ8M inverters. Those were selected because our arrays were east and west facing. If they were south facing, I would have gone with the IQ8A in this case. Again, we did a line side tap. We have a metal roof mount. We have 3 of the 10 kilowatt hour batteries, and we have a sub panel. So when I get the layout back, you can see that the engineers opted to switch from a portrait to a landscape orientation on the panels, and that made a little bit better use of the roof space and ensuring that we had these fire setbacks here. It made no significant difference to the appearance or the production of the system. In fact, it might have optimized it a little bit. When we look at the equipment, again, we want to make sure the panels and the inverters match and we have the correct battery and number. So as we look down, this is all of our roof mounting equipment. Here we have our 78 panels and 78 IQ8Ms. 2 combiners, those are where all of the, essentially the wires, all of the electricity from the Enphase inverters comes in, gets combined, and then goes into the house. A bolt down breaker, that's specific because we used Sonova for financing, they require that. The rest of our breakers for interconnection, our breakers for our battery, they had to do a D-rate in this case because of the utility. And then 3 of the batteries, the IQ system load controller, and a 200 amp sub panel for the backup. So everything looks good here. We're checking the mounting hardware, so that's further down in the plans. And because this was a metal roof, we're seeing the metal roof mounts, which is what we want to see. So everything looks good there. And you can see that they are speccing this out for a manufactured steel truss. So that's going to play into how far apart the mounts need to be and what type of lag bolt or screw they're going to use. So making sure that that is accurate too, that can save you some headaches later down the road. Now, this is a very busy line diagram here. And you can see basically you have all of the panels up here. The system is divided into two systems, one going into each of the envoys, each coming down into their junction boxes into the IQ combiners. In other words, an envoy. Each of these systems will then come down here and feed into the panel eventually by way of a line side tap. As you can see, the batteries are nowhere in this line diagram of the solar because it's an AC coupled battery. We do have consumption CTs on here again. I mentioned this was a Sonova system. Sonova does require that. It's a good thing to have, and I believe you get it by default on any battery projects anyways. Now into this 200 amp panel that we have here, we have the system feeding in. And then you can see down here, we've got 3 of our batteries, that Encharge 10 kilowatt hour battery, each of these feeding in through its own combiner and coming into the system as well. And then feeding out here through the disconnector, through the transfer switch, into our 200 amp backup panel. So once again, everything here looks right. Now, I know I just covered the whole system, including the batteries, but we really want to make sure that we have the right panels, the right inverters, and then the right number of batteries, the right specific battery. And you want to make sure that they have the right type of backup specified. I've had some issues with this in the past where the installer is coming out expecting to do one type of backup and the customer is expecting another. And as a consultant, you're expecting another. And somewhere along the line that got missed. So when you're reviewing the plans, you want to make sure that it looks like they're backing it up the correct way. In this case, they're running it through a sub panel, but it is a 200 amp sub panel. And they're going to be able to back up those heavy loads that they were looking for. If you were doing a true whole home backup, you would just have the transfer switch disconnecting the main panel. You would not have a separate sub panel. So just a couple final take home messages. These are definitely easy to get overwhelmed with, especially the line drawings. If you've never looked at them before, look back at some of your projects and just review and try to get a sense of what you're looking at. Better to do that on your own and when you can ask questions than when a homeowner is asking you a question or asking you if it looks good, because Power is now sending these directly to them to approve. So you really want to look like you know what you're talking about if that homeowner calls you after they receive it and have a question. And like I said, it really helps to pick up some issues early in the process that can avoid delays and definitely make you look better with the homeowner and make you look. If you made it this far, great job. This was a quick video. It was a very detailed video. Any questions, reach out to me. Text is best if you're going to use the phone, or shoot me an email. And we are always hiring. So if you want to come work with us, you can reach out to me or follow this link right here. So the next one, which will hopefully be much more frequent than they have been.